Hello, everyone. Thank you for joining today. I am here to talk about GPU acceleration for XGBoost and scikit-learn, but it will be mostly about XGBoost. A little bit about myself. Sorry. So I'm Jiaming Yuan. I work for NVIDIA, and I also help maintain the XGBoost project on the public GitHub repository. So you can reach out to me. This talk will be in English, but I also speak Cantonese, so feel free to reach out. How many of you have used XGBoost with GPUs before? Okay, one person. Okay, great. I will give a brief introduction, and then I will dive into some of the GPU stuff after. Yeah, it will be mostly about scaling with GPUs. We are not satisfied with a single GPU anymore. It's a machine learning library for building decision trees and with the gradient boosting algorithm. So if you are doing something other than data science, then this talk is probably not for you. But it's fine. It's a good choice to be here. Yeah. Right. So it has a couple interfaces and try to be a good citizen and support everyone and make everyone happy. Yeah. On the other hand, QML is our GPU accelerated version of scikit-learn, and it tries to be fast. It has additional algorithms other than those implemented in scikit-learn. And it also has an inference library for others to deploy the tree models. We also have some sister projects for data processing and Task interface for distributed training. So Task is a Python distributed framework for running your pipeline on multiple machines, including GPUs or CPUs. I will walk through some of the features in XGBoost in the latest development, but I won't dive into it due to the time limit. Sorry. So in the past, we supported only numerical features, but now we can work with categorical features as well. And we are also working on multi-target models. As I previously mentioned, there is an inference library from QML for the integration, and it is based on the new model format. You can save those machine learning models in JSON or UVJSON, and then you can build your own tool strings based on this model format for visualization and whatnot. For more examples, you will have to visit our gallery in the document, but also feel free to reach out afterward if you have questions. Because I work for NVIDIA, I should focus on that. In the past, for convention, I should show you a lot of charts that shows you, hey, this is GPU, this is 4 times faster than your CPU, just switch, don't do anything. But for this talk, I want to deviate a little bit and talk about some of the difficulties we ran into when working with GPU. It all comes down to memory usage. So GPU has a really small memory size, but our datasets are getting larger and larger. So many algorithms are not like the neural network training, and we have to put the entire dataset into the memory in order to be efficient. And that includes gradient boosting for building decision trees. So we run into this conundrum. We want you to use GPU, but for small datasets, you probably don't care about acceleration that much. And for large datasets, you are running into out-of-memory error. So we can't sell our GPUs, and that is the problem. So we need to come up with solutions, and unfortunately, there is not a simple solution. We have to do many optimizations and integrations. So XGBoost has been trying to support GPUs for a very long time. It's not a news. And we have integrations with many libraries. The integration is not just at the interface level. It runs much deeper. So for example, all these libraries I just talked about can share a single memory pool through the use of Rapid Memory Manager. And that helps us to increase the memory utilization for our GPU. Aside from the ecosystem from sister projects, we also need to look into XGBoost from within and try to utilize more the memory better. But there is a limit on what we can do with a single GPU. We have to scale up, and that's what we have been doing. So this is the first time I talk about the NVLink in public. So if I make mistakes, bear that in mind. So there is no denying for many libraries, including XGBoost, when dealing with data science problem, it will eat all your memory if it can. And as long as you have memory, the algorithm can eat it all. And so what can we do? So I'm sure most of you here have tried one of those large language models. If you haven't, then I don't know which rock you are living under, but yeah, come out. So we want other libraries to be as like those neural networks. And those neural networks are massively popular, and it is for good reason, because it is so easy to scale, at least compared to other algorithms like gradient boosting. And we want to be like that in terms of scalability. And we have been trying, and this time we are getting much closer than before. So XGBoost has this feature called external memory, where you can fetch data from a different location to the main memory batch by batch during your model training. And in before, we couldn't do it because we couldn't make it efficient enough to justify doing so, because PCIe link is so slow. Even with the latest gen of PCIe 4 or 5, they are so slow, and it takes much longer to transfer the data from one place to other than it is to process the data on GPU. But now, with NVLink, we can transfer the data much quicker. So here is a comparison. I'm not sure if you can see the profiling so clearly. This is PCIe. It takes much more time to transfer the data than it is to process them. Wow. This is the NVLink version. As you can see, the speed is much faster, and the overhead for data transfer is much lower, and you don't see any wide gaps between computations. Right, so that is the good thing. So, out of the two persons, what's the largest data set you have used with XGBoost and GPU? Okay, 0%. So probably around this number, or maybe less than 30. So in order to join this talk, I increased from 60 gigabytes to 1.2 terabytes. I was expecting more old users from here. We are back to the grand NVIDIA tradition, and I need to show you the GPU performance. So we are getting closer just to the deep learning side. We are processing terabytes of data on a single node, but we are still not happy, at least not satisfied enough. And we want to do an entire cluster. So imagine a single node can process a terabyte of data, and what we can do with large clusters. In this step, we are getting much closer to those large language models for gradient boosting and decision trees. So you might not care about distributed training. Not many people have that much data, but when you try to do hyperparameter optimizations, it starts to matter, because Yeah, for a terabyte of data, it takes a very long time to do a one training section. And then if you want to do actual optimization for those hyperparameters and grid searching, 5 minutes. You have to use more than one single GPU, otherwise it will take much more time for you to train the model than it is for you to receive new data. And as I mentioned, we are trying to be the good citizen and make everybody happy, and we are supporting multiple interfaces. So this is PyCon. I will talk about Dask and PySpark, but feel free to reach out after the talk and for some other interfaces. Right. So if you have used one of those old tradition, let's say, tradition Python data stack like NumPy or pandas, then you should be quite easy to get familiar with the Dask stack, because it basically mimics the NumPy and Python NumPy and pandas interface. So one advantage is that basically I can test my code on a laptop. You don't have to memorize those snippets. They are all on the documentation, and it's fine. So basically I can test my code on my laptop and then scale it up all the way to clusters based on Kubernetes or based on your HPC. So it also has Slurm clusters. And more importantly, it also has an entire ecosystem for things like GPU data processing and for hyperparameter optimizations. We do a lot of integration with it. Here is a moderate dataset with profiling result. And for more examples and tutorials, visit our documentation. We spend a lot of time into creating these examples. Yeah, this is from my colleagues, and they are working on PySpark support, and it is working pretty well. So if you have infrastructures for Spark applications, you can try PySpark as well, and it is just as mature. So this is based on the Spark Rapids project, and it is the building blocks for GPU acceleration for Spark, and it works for both Java and Python, but I don't work with Java. So yeah, it helps XGBoost to build the entire pipeline from ETL to model training, and it aims at faster than CPU and cheaper than CPU. So yeah. Any question? 0%. Yeah. Yeah, you need to start from scratch, unfortunately. So Python serialization is not quite standard. It's always just pickled. Yep. Anything else? No, then. Yeah.
You can ask them afterwards. Okay, I guess that's us. We'll see you back here at 2 p.m. There's going to be a lot of talks in here and in other rooms. Yeah, thanks again for coming to PyCon 2024. See you at 2 p.m.